Hello, my name is Dr. Roderick L. Roll, and today I will be talking about factors that affect chemical agents. We will discuss 8 factors that affect how the germicide will work. The first one we will discuss is time. So time is a factor when determining if a disinfectant is going to work and how efficient it will be. So we know that chemical agents do not all kill at the same time. Some of them take longer to kill than others. So in this image, we have one chemical agent that was tested to see how long it would kill 1 billion bacteria. As you can see from this image, after about 2.5 minutes to 3 minutes, the number of bacteria decreased from 1 billion to 1 million. At about 5.5 to 6 minutes, only 1,000 of those bacteria were left. After 9 minutes of this disinfectant remaining on the surface, it killed every bacteria that was there, which originally was 1 billion bacteria. So therefore, this slide shows you how time is a factor in killing bacteria. Does this work? If you spray a disinfectant on a surface and then wipe it, will it work? No. Based on the previous slide, it requires time. So how many minutes will this disinfectant take to kill all of the microbes? Temperature is a factor when determining how effective a disinfectant is. Killing efficiency increases as the temperature increases. So based on this slide, it proves this statement. This is one disinfectant, and they're using it at 2 different temperatures. The first one is at room temperature, around 20 degrees Celsius. It would take about 11 minutes to 12 minutes to kill all of the microbes on the surface. But if we heated up the surface from 20 degrees Celsius to 45 degrees Celsius, just a little bit warmer than body temperature, it would only take 4 minutes to kill all of the bacteria on that surface. So temperature is going to increase the killing capability of some disinfectants. Antimicrobial effects of heat are further enhanced in acidic environments. So if the solution was slightly acidic, 20 degrees versus 45 degrees, the 45 degree solution, the killing capability would be enhanced. The next factor to be considered when determining the effectiveness of disinfectants will be pH. Some disinfectants like sodium hypochlorite, the active ingredient in bleach, is more effective at low pH. Here is the chemical equation of bleach when placed in water. When the pH of bleach is below 7, the equilibrium favors hypochlorous acid. At pH 7.4, the solution would have 50% hypochlorous acid and 50% hypochlorite ions. The microbial effect, the antimicrobial effect, is instigated by hypochlorous acid. So as we go above 7.4, the proportion of hypochlorite increases. This is not going to make the solution more effective at killing bacteria. The pH where bleach is most effective is around 4 to 5. So essentially all the chlorine is present in the hypochlorous acid ion formation. This is actually 2 to the order times stronger or more effective in killing than hypochlorite ions. As the acidity increases even further past 4 towards the pH of 2, more chlorine dioxide gas molecules will form. These gas molecules are going to be lost from the solution. Therefore, they will not be there to help in the antimicrobial effect. So pH of 2 is not as effective at killing the bacteria. The next factor to be considered in how effective a disinfectant is the concentration of the microbe that's in the solution or on the table. As you increase the number of bacteria, it will take longer to kill. As the number of bacteria decrease, the disinfectant will not have to remain as long. The next factor to be considered is the type of microbe. We have created 3 groups based on the susceptibility of microbes to disinfectants. The more susceptible, they will be in group A. The more resistant, they will be in group C. The most resistant microbes include bacteria like Clostridium or Bacillus. These are endospore producing bacteria. Endospores have been known to survive 20 years in 70% isopropanol or 70% ethanol. Some endospores have even been found in the Egyptian mummies. Another very resistant microbe is Mycobacterium. Microbacterium has a waxy lipid coat that helps protect Mycobacterium from penetration of chemicals. The other end of the spectrum is the microbes that are most susceptible to these disinfectants. They would include the viruses. Enveloped viruses such as HIV can be destroyed more easily than a non-enveloped virus like the polio virus. Viral envelopes are more easily destroyed than the protein coat of non-enveloped viruses. In the picture below, we're looking at the polio virus versus the HIV virus. The HIV virus has a capsid and an outer envelope. Even though it has an outer envelope, that virus is easier to destroy than the one to the left, that is the naked virus. Extraneous matter is another variable to consider when determining which disinfectant to use. In the slide, you see a toilet that has vomit on it. Sometimes the extraneous matter will deactivate your disinfectants. So it must be cleaned first. We all have seen a child throw up in the elementary schools. What do they do to clean is they put some kind of powder on top of it. They scoop up the powder, put it in a bag, and then they spray a disinfectant on it. This is how you clean up spills that contain these extraneous materials. So when using Mr. Clean on vomit, you first need to remove the vomit. After you have removed the vomit, if you leave the disinfectant on for 1 minute, it will clean, versus 10 minutes, it will kill most microbes. So you first remove the debris before you apply the disinfectant. Some of these extraneous materials include feces, fat, vomit, blood, and biofilm. The next variable you must consider is the presence of biofilms. A biofilm is a community of microorganisms that can reside on surfaces. These communities must be removed first for the disinfectant to actually work. Most of the disinfectants cannot penetrate the community. Therefore, it will not be able to kill the microorganisms. So you must use an abrasive material and some kind of abrasive disinfectant like Comet or Ajax. This can help to dislodge or break up the community. Once the community has been broken up, then the disinfectant can do its work. So within biofilms, the microbes can resist the disinfectant. This slide shows you the sliminess of a pipe. This sliminess is the actual biofilm. You can't just spray Mr. Clean into this pipe. You must first dislodge, break up the community with something that's abrasive, maybe a rag or a Brillo pad. The next factor to be considered is the concentration of the disinfectant. In this slide, we're looking at bleach. Some bleach that you can purchase from the dollar store might still be labeled Clorox, but you have to look at the concentration of sodium hypochlorite. In this bleach container that's labeled Clorox, you have 6% sodium hypochlorite. And some that you might purchase at Family Dollar or the Dollar Tree might have 5% or 4% sodium hypochlorite. So the concentration of disinfectant is a factor to be considered.